So today let us see about the formation of LPP by using some blending problem, and here today we are taking a manufacture of some chocolates. So let us manufacture some chocolates. So this is what the problem given. Consider a chocolate manufacturing company that produce two types of chocolates A and B. Both the chocolate required milk and choco, and the units of milk and choco requirement for the manufacture of A and B is given here. So 1 unit of milk and 3 units of chocos for required for A, and 1 unit of milk and 2 unit of chocos required for B. And the total availability of milk and choco in the company kitchen is also given. 5 units of milk and 12 units of chocos are ready. Okay, and the company make a profit of rupees 6 per unit A sold and 5 per unit B sold. The profit is also given, and the problem itself, it is given as it given it is a maximization problem. Also the profit is discussed here, so we need to maximize the profit. Obviously the problem is a maximization problem. So let us frame the given problem into the linear programming problem, right? So let us derive mathematical equations for this problem. So first we can tabulate the given problem. So what are the requirements given? So let us tabulate the given problem like this. So here A and B, two types of chocolates are manufactured, and both the chocolates requires milk and choco. So table was formulated tabulated like this. And for A requires 1 unit and 1 unit of milk and 3 unit of choco. So I'm putting a unit 1 and 3 in the respective row, and for B row I'm taking a putting the unit 1 and 2 which is given in the question. And also the total availability is given in the question itself. It is a 5 and 5 unit of milk and 12 unit of choco. So total is given here 5 and 12. And the profit is also given in the question itself. For A it is a profit is 6 per unit, and for B it is a 5 per unit. So now our total problem is tabulated like this. So let us write the equations objective function first. So here the problem is a maximization problem. So first we can write the max z value. For that we need to find out the decision variable. So here two decision variables are involved. One is for unit A and another one is for unit B. Let it be x and y. So the maximized z is equal to 6x plus 5y. 6 is a profit for unit A, and B 5 is a profit given for unit B. So max z is written like this, 6x plus 5y. So let us frame the constraint part. The limited for source is also given. The total availability is given as 5 and 12. So it can be written like this for a milk requirement for A and B and the total availability. So using these data we can frame the first constraint. So it is written like this, x plus y is less than or equal to 5, and the choco part it is written like this, 3x plus 2y less than or equal to 12. And your x and y each value always greater than or equal to 0, and this condition is said to be the non-negative conditions. Okay, so altogether we can formulate a given problem as a mathematical model. So this is what the mathematical equation max z is equal to 6x plus 5y, and subject to constraint x plus y less than or equal to 5, 3x plus 2y less than or equal to 12, and x and y greater than or equal to 0.